morning. Good day, everyone. This is Diane Fodell. Thank you for joining the Cognitive Systems Institute speaker series. This morning, I'm happy to introduce Murray Campbell, who is a distinguished research staff member in the AI Foundations Group, part of the Cognitive Computing Organization at the IBM T.J. Watson Research Center. The mission of the AI Foundations Group is to use machine learning approaches to advance artificial intelligence technologies and applications. Murray's primary research interests include end-to-end conversational systems, deep learning, and deep reinforcement learning. Prior to his current position, Murray has had a number of management roles, including smarter workforce, multimedia data, and anomaly detection. In his first project at IBM Research, Murray was a member of the team that developed Deep Blue, the first computer to defeat the reigning world chess champion in a regulation match. Murray has a computer science bachelor and master's degree from the University of Alberta and a PhD in computer science from Carnegie Mellon University. Welcome, Murray, and thank you for presenting today the role of dialogue in augmented intelligence.
Thank you, Diane. So I think the term augmented intelligence has been receiving a lot of attention in the past 2 or 3 years. And as a part of this talk, I'll explain what I mean by augmented intelligence, why I think it's going to be important over the next few decades, really, and how natural language dialogue can play an important role in augmented intelligence. So, I think if we think of augmented intelligence as humans and computers collaborating to achieve a goal, and I guess there's a distinction there between partners and tools, I'm thinking more along the lines of partners, then my feeling is that for the foreseeable future, artificial intelligence in many practical real-world problems will in fact be augmented intelligence. I think we're too far away from fully automating many difficult real-world problems. Now, to be clear, there are many problems that can be automated, and this is not arguing against that. It's just that many of the real challenging problems will have to be a hybrid of humans and computers working together. So if there is to be collaboration in these augmented intelligence systems, there needs to be some sort of communication between the human and the computer agent to coordinate their work. And in some cases, but certainly not all, and I'll talk about that, dialogue is an appropriate method of communicating. So combining augmented intelligence with dialogue presents a number of interesting research challenges. And of course, this is an area that has seen significant attention in the past. For example, Barbara Gross has done a lot of work in this space. But I think it's different in recent years because of the success of deep learning. And I think that I'll try and convince you that that presents some promising new directions and some interesting new challenges. So one sort of informal definition of augmented intelligence is humans and computers can achieve better performance than either one can by themselves. So this clearly isn't always true, but when might it be true? And the most obvious important criteria is that the human and the machine bring complementary capabilities to the table. So in the cartoon on the right, you can see if we say a computer has certain capabilities, but gaps in, for example, creativity or goal setting, common sense reasoning, and they're not so good about dealing with rare cases. Whereas human capabilities have usually different gaps. Gaps in the ability to in memory, in the ability to focus across a large set of possibilities, in carrying out large-scale search, and so on. So if they're complementary, like in the final of the three pictures, we hope that some of the gaps in the system are covered, and the combined system is able to perform better than either alone. Of course, there's another important criteria where augmented intelligence makes sense, and that is that there's a way for the human and the computer to communicate. And the benefits of this collaboration, the gap covering, so to speak, outweighs the cost of the communication, because there will be a cost to the communication. So some examples of augmented intelligence, some are very obvious and have been around for a while. One is aircraft autopilots. That's a form of augmented intelligence where in the long periods of time between airports, the pilot turns it over to the autopilot, and then when unusual things happen, the pilot, or including landing and takeoff, the pilot can take over and handle that. But in recent years, we've seen in areas like legal discovery, where pouring through large amounts of documents trying to find certain relevant material used to be done largely by hand. Then search engines became helpful there, and now an even more close collaboration where it's interactive searching through these documents. And there's also healthcare is a great example. There's this interesting study between IBM Watson team and the University of North Carolina, where they looked at 1,000 cancer patients, and some of these were the toughest patients that had been reviewed by a board of physicians, and in 99% of those cases, there was a match between the automated system, the Watson system, and the doctors on the recommended treatment. But, and this is the important point, in 30% of the cases, the Watson system was able to recommend alternative treatments that had been missed by the physicians, partly because doctors can't read everything that's going on in their field all the time. There are new papers that come out all the time, new clinical trials, recently approved drugs that they may not be aware of. And so having these options would potentially allow the chance for improved treatments. And there's one other example which can be very precisely quantified as to how augmented intelligence helps. On the graph on the right, you can see this is a graph of computer performance over time. The purple line is the performance. Well, the blue line first is the performance on a arbitrary rating scale called the ELO rating of the top human in the world, and you can see it goes up and down, but there's been a general trend upward. The top 10 humans has smoothed out of that a little bit, and you can see again a slow trend upward over a period of a few decades. Computers clearly have started way behind humans and gone way past where humans can do, and at this point, computers are far superhuman in chess. But the green line, which is dashed because it's based on some data that's still somewhat speculative and needs more analysis, but there's a lot of evidence that humans plus computers are better than either alone, and this gap has persisted for many years since it's being started to be measured in the late 90s, and it still is there today, although getting harder and harder to find. Another kind of interesting example, and this is related to the communication issue, again from computer chess. If you take a look at this graph and see that the blue line is human ability, but the x-axis this time is how much time you have to make a decision. And you can see that in blitz chess, where you have only a few seconds to make a decision, humans don't perform all that well. And it gets better when they move up to 30 seconds a move, and then even better at 3 minutes a move. And if you give them 3 days to make a move, something called correspondence chess, they get, obviously it continues. When you look at computers, they still improve over time, as you might expect, when you give them more time to make a decision. But the interesting point is the green line, where the humans plus computers continue to improve as you get more time to make a decision, showing that there's some sort of interaction that needs to take place that maybe takes some time to sort out. And if you can take that time, the human plus computer is significantly better than either alone, even with modern day computers. So, hopefully I've convinced you that augmented intelligence is an important area, and in that example that we showed for chess, augmented intelligence systems can surpass computer-alone systems for many, many years. So the question is now, when is dialogue a useful way for communicating between humans and computers in these augmented intelligence systems? There are a few criteria. One is that you have to have sufficient time to make a decision. If it's a real-time interaction, for example, a self-driving car, you don't imagine that it would be useful to have an interaction saying there's an obstacle in the road. I think you need to take more immediate action. So you need to have time to interact and figure out over a few steps what's the best decision to make. Also, there needs to be sufficient complexity to justify an interaction. If it's a simple decision, it's obvious what to do, you don't need to have an interaction. It also has to be an important enough decision to justify an interaction. If it's simply which movie to recommend to a customer on a website, I don't think you need to have an interaction between a system and a human going back and forth trying to say, should we recommend this movie or that movie? Because the cost of making a wrong decision isn't huge, and the computer decisions are likely to be good enough. An additional factor for when dialogue could be important is when explainability is important. By that, I mean that many modern day artificial intelligence systems tend to be somewhat black box if they're based on deep learning or machine learning. And if you can find ways to explain decisions better, in particular through language such as dialogue, that could make it a useful part of an augmented intelligence system. When the goals and the preferences of the human agent are complex, the system that is being collaborated with needs to understand those in order to recommend a good decision. And that one way to do that is to have a dialogue interaction. And there's a few others. I won't go into details on all of the points, so I have time to cover all my material, but you can see that there are many instances in which dialogue can be a useful part of an augmented intelligence system. So let me, before I go a little deeper into that, let me just talk about some of the challenges that dialogue systems have and why this just isn't a trivial thing to do. Take your AI system, hook up a dialogue interaction with the human, and you're done. In fact, dialogue approaches are rather difficult. Well, they're easy in one sense in that you can script up and for a simple problem, you can script up a solution quite quickly, but they don't scale to complex problems. And so our feeling, and the feeling of many other research teams around the world, is that a learning approach to dialogue will be important rather than a purely scripted approach. But unfortunately, it's very difficult to evaluate and measure and even annotate a dialogue to decide what is good performance and what is bad performance. In the most extreme cases, it can be done, but for a typical dialogue, it's hard to tell if it was the example statements that are in there were the best possible statements, or whether they 7 out of 10. This is an active research area, and I believe that a lot of work needs to be done there in order to enable learning approaches to dialogue. Detecting and expressing emotion is an important part of dialogue. People respond much better if the system that they're interacting with can at least understand that they're frustrated or confused, and change the way they interact in those cases. And there are a few others, dialogue challenges, that make it a really challenging problem, and this is going to be a very important research area for the next decade at least. So I'm going to just give an example on the last one of reasoning, and show that it'll lead into some work of ours at IBM Research that I want to show you along these lines. So you can see in the yellow a couple of examples of automated dialogue systems where they might fail because they don't do some simple reasoning that is just so routine for humans that we don't even think about it. I want to add my wife to our insurance policy. The agent says, okay, I can help you with that. Is she an immediate family member? Now, obviously there is information out there in the real world that could help a system avoid a mistake like this, but incorporating such reasoning into dialogue systems is a very challenging research problem. So I want to tell you about some particular work that we've done, and that's related to this area, and I think it's first steps into incorporating dialogue into some sort of reasoning kind of problems that can eventually lead to augmented intelligence. So I'll start by describing very quickly something called the baby task, which was described by Facebook a couple of years ago. The idea is that you give your learning system lots of examples like this one right here. You tell a little story. It may be just a few lines long, and it's obviously a very stylized and simple story. And at the end of that story, you ask a question. So in this case, where is the gift? And we can look back over that story and say, oh, Hannah picked up the gift and she went to the kitchen. So when I'm asked where is the gift, I say, oh, the gift is in the kitchen. And we did a little bit of reasoning there to be able to answer that question. And there are around 20 different kinds of questions that can be asked in this space. And the goal is to develop systems that purely by be shown hundreds or thousands of examples of these stories and a questions and the right answer, it can learn to read a new story and, given a question on that story, answer it. And modern day systems are very good at learning how to answer these kinds of questions on admittedly relatively simple stories, and then scaling this up to more real world problems. So we need to find an extension of this to make it more dialogue-like. So we tell a story, as in the baby task, and you can see that there's one difference in this story, and that at step 4 we say someone goes to the kitchen. Now, this, if I ask you now, where is the gift, you realize that you in fact don't have enough information to answer this question. And our system has to learn when it has enough information to answer a question and when it doesn't. And if it doesn't have enough information, go and ask another question. Start a dialogue, an interactive dialogue, to figure out what it is you need to know in order to answer the question. In this case, if you're asked where is the gift, you have to know in statement 4 who actually went to the kitchen. Was it Hannah or was it Emma? If you hear that it's Emma that went to the kitchen, then you know that the gift didn't go to the kitchen and the gift is still in the garden. So given examples of these kinds of short stories with these ambiguities that are introduced, and lots of examples of questions and answers that could be asked about these stories, we have a system that learns to interact and reason and ask questions about these stories that it's never seen before, and can answer almost perfectly on short stories similar to this one, and even on much longer stories with multiple ambiguities can get more than 80% correct on many of these stories. So there's a link in the bottom right corner to a paper on this that is going to be appearing at the iClear conference later this year. So let me wrap it up. I believe that augmented intelligence systems are likely to be important for many decades to come. There are just too many real-world problems that we don't know how to completely solve yet, but people are very good at. And so the combination of humans and computers together can be very effective. In some cases, and I gave you an example of what kinds of cases that might be, dialogue may be the best communication mechanism for these augmented intelligence systems, particularly if you have sufficient time to interact between the systems, between the human and the computer. But there are still many significant research challenges in adapting dialogue systems to augmented intelligence systems. In particular, the biggest challenge is creating a system that can learn how to produce a dialogue, to interact via dialogue, rather than be scripted. Scripted approaches are effective in small domains, but learning is, we believe, the way forward. And with that, I'll wrap it up and see if there's any questions.
Thank you, Murray. Audience, I'll ask you to press *1 on your phones to unmute your line and ask questions.
Hi, Murray. This is Jim Sporer. Thanks for an excellent presentation, as always,
Thank
from
you.
Do you think it's always true that it's intelligence augmentation when the person provides the purpose or task? For example, when a person can make money when a task is solved or an outcome is achieved, isn't that, intelligence augmentation always true in that case, if you follow me?
Yeah, so if there's something if there's one interaction at the beginning, so here's your task, go and do this, and then it goes out and does it, I don't really consider that as augmented intelligence. That's more automated.
Okay.
These are not precisely defined terms, and one can argue about that, but in my mind, some sort of interaction is critical to the definition of augmented intelligence.
Mm-hmm. Yeah, in service science, this is the area that we call value co-creation and versus co-production, and how much of the work is on both sides of the equation. So it's very relevant to the service science community. And one other quick one, is common sense reasoning a prerequisite for intelligent dialogue in general? It seems to be based on the examples you gave. So is common sense reasoning a grand challenge that really has to be solved before we can really solve the dialogue problem in general?
I think there are many real-world problems that can be handled without necessarily cracking common sense reasoning by just hand coding the small subset that's necessary for the particular domain. But as we get to more complex problems, for example, in healthcare, I think in order to not be annoying, these systems will have to have some level of common sense reasoning so that they don't continually ask to confirm things that are obviously true and make stupid errors that that no 8-year-old would make. So I think in the long run, yes, but in the short run, there are some applications where I think we can make do for now.
Great, thank you.
Hi, Murray. This is Karthik. I just wanted to chime in on a point that Jim made. I think it's important also to look at the roles, right? So if you think about things like delegation versus teamwork, right? I think augmented intelligence is much more useful in the second case, in the case of teamwork. Delegation is the case that you were talking about, Murray, where you just hand off a very well-defined goal to an agent, and then it has an automated way to achieve that goal. So there are actually lots of people in the human factors communities, the human-computer interaction, the CHI, CSCW kind of communities that are looking at these sorts of things. And actually, these are well-defined concepts, and there are metrics to back some of these things up, things like cognitive load, team efficiency, blah, blah, blah. So I think it's useful. I mean, obviously, as AI people, we are looking at this from a systems perspective. We're looking at this from an algorithms perspective. But I think we should also look at some of these predefined ideas of delegation versus teamwork and so on, and some of the metrics that go with it, because I think that will help us both in defining some of these scenarios more crisply, and then it will also help us when it comes to generating things like explanations, for example, because there are different kinds of explanations that might rate differently on, let's say, a cognitive load metric, for example. And there are different models and at different levels of abstractions for different kinds of users and things like that. So I think that's a connection that we ought to make if we eventually want integrated systems in these.
Yeah, a lot of great points. And for those on the phone who don't know Karthik, he's a researcher also here at Yorktown who's worked in human agent decision making in the past, and so he's a good person to reach out if you're interested in some of the topics that he talked about.
Hi, Murray. Can you hear me?
Yep.
Hi, Ken Forbes.
Hi, Ken.
Hi. Great talk. In addition to learning, I think one of the big missing pieces in dialogue is reasoning. So think about it this way. In all the examples where you're doing a dialogue and the two of you or the N of you are working towards a problem, then there's a shared space that you've got, and you're reasoning about the connections between what's being said to that shared space. Part of the reason why the learning approaches seem to be pretty shallow is they don't actually capture that implicit information. James Allen has this beautiful model called the collaborative problem-solving model of dialogue, and we've used it quite successfully in building dialogue systems. And they get the flexibility not because of machine learning, but they get it because they're doing reasoning. Oh, here's what this person said. In this context, what they must mean is this. And
yeah,
so
I just wanted to add one thing, then I'll let you continue. So I think that the system that I showed on the previous chart is learning a very simple and very shallow form of reasoning, but I think that will only get us so far, and to do a more symbolic kind of reasoning and integrate that with learning approaches is definitely the way forward in my mind.
That's what I thought you'd say. Okay, just checking. All right, thank you.
Thanks, Ken.
Well, thank you, audience, for your questions. Thank you, Murray, for being our presenter today. I'm afraid we're out of time, but I encourage you to continue the discussion with Murray in our LinkedIn discussion group. I'll post something about this talk there. And thank you all. We will have another great speaker next week, and I'll look forward to seeing you all then. Thanks again, Murray.
Thanks. Bye.
Bye, everyone.